Hi guys, this is for lesson 7.15 and also 7.16. There isn't really a second PowerPoint for that. It's all in under 7.15. This is bond association energy, and I'm going to also include for molecules. I'm sorry, for a reaction. Okay, so first off, you're going to need that chart that I gave you with the classwork. It should be classwork 7.15. You must use this one that I gave you to be calculating for the test or quizzes, because this is what I'll make the key for. This is the energy required to break apart covalent bonds. Okay, so you need to use those ones that I gave you. You cannot just Google them. They'll give you the wrong numbers. The larger the dissociation energy, it means the stronger the bond. So here's the process. You first need to draw a proper Lewis structure. If you draw this improperly, you will get the answer wrong. Okay, so I cannot stress this enough. If you still need help with that, I did make a video for that. You need to determine what bonds are present. Are there double bonds? Are there single bonds? How many are there? And you add all the bond energies together, and that equals the energy to break apart all bonds within that molecule. So this is the one that I gave you, okay? This is the one that you should use. I will try to post a link to this on Canvas if you need to print this out again, because for whatever reason you need another copy, that's fine. But again, use this one. This will be all the value, because everybody has slightly different values, and so you're going to get the answer wrong if you use a different chart. I want to bring your attention down here to CO2, 799 and CO2. You have to multiply that by 2 because there are 2 double bonds for carbon and oxygen, right? So for this, it's just if there's one, but CO2 has a stronger bond and therefore a bigger number. But don't forget, you have to multiply it by 2 because there's 2 of them. All right, so first, let me show you what we're going to do. It's very simple. You have to draw the molecule, and when you draw this molecule, you'll find out that there is a single bond between one chlorine and another chlorine. So all there is one bond to break, and that's a single chlorine-chlorine bond, and that is found right here, 243. Okay, so we get 243, and the units are up at the top of the chart, kilojoules per mole. For this one, carbon bonded to chlorine 4 times. And it's a single bond when you draw it out. So you have to multiply that number by 4 because there's 4 of them. So where is carbon and chlorine? Here it is. 339 times 4 because there are 4 of them. Okay? And so that gives you the total of that, 1356. All right, for CO2, like I just talked about, there are 2 of them. Okay, so you take that 799 at the bottom and multiply it by 2 because there's 2 bonds. For CO, that is a triple bond. That is a single, triple, that sounds confusing. There's only one connection here, and it's a triple bond between carbon and oxygen, and that number is right here at the bottom, right here, 1070. And that's the only thing that's in that molecule to rip apart, so that's the number that you write down. For this one, if you draw the structure properly, you'll find that there is a double bond between carbon and oxygen, and then there is 2 single bonds between hydrogen. Okay, so this is the 2 single bonds between carbon and hydrogen. Okay, so it's 413 multiplied by 2. Then you add that the double bond between carbon and oxygen. Notice it's 745 and not the 799 if we go back to the chart. This number, because we're not talking about CO2 anymore. We're talking about just a regular old double bond between carbon and oxygen. Okay, that's it for a molecule. I'm going to jump into the next lesson, which is for an entire reaction. Okay, so this is the energy that's either absorbed or released in a reaction. And what you do is you add all the energy of the reactants together and you subtract energy of products. So remember, reactants minus products, okay? If your answer is positive, okay, you need to know this, it means energy was absorbed and it was endothermic. If your answer is negative, which it usually is, it means energy is released and it's exothermic. So you need to know this association, okay? So just make sure. If there are coefficients, you must multiply by those coefficients by the total of that molecule, okay? All right, so again, we're going to use this first chart that I gave you. Everything is all the same. I will try to post a link for that on Canvas if you need it. So here is our first reaction. Now, this is an unbalanced reaction. I just wanted to make I just wanted you to see what it would be like if I had coefficients, okay? So I've got 4 CH4s and 1 of the Cl2s, and I know there's 1 because there's no coefficient in front. I have 2 of this entire molecule and 1 of this molecule, okay? So what I'm going to do is I'm going to get the total of this molecule and all the bonds and add them up and then multiply it by 4. For this one, I'm going to get the total of all these bonds together and multiply it by 2, okay? And then add in this guy. So that's what that looks like, okay? I have 4 of this entire thing. There are 4 carbon-hydrogen bonds. So I took the carbon-hydrogen bond, multiplied it by 4, and then multiplied it all by 4 again because of that coefficient. Then I add in a single chlorine-chlorine bond. That gives me a total of this for my reactants. That's everything to the left of the arrow. For the other one, for this guy right here, there are 3 single carbon-hydrogen bonds. That's this number, multiplied by 3. And then I'm going to add in my carbon-chlorine bond. That's this guy. I'm going to get that whole total and multiply it by 2 because of this coefficient right here. Then I'm going to add in my single hydrogen-chlorine bond in there. So I'm going to get a total of my products of this. And then I just subtract. Okay, it's just simple subtraction. And I'm getting a positive number here of the difference. That means that energy is absorbed, and this is an endothermic reaction, meaning I had to put energy in for this to take place. Okay. For the next problem, I have CO2 plus H2, and it's going to make 3 carbon monoxides and 1 water. Okay, I actually have my animation is out of order here. So here's this guy. Here's my reactant. So I've got 2 CO2. I have 2 double carbon oxygen bonds. That's this guy. Plus 1 hydrogen-hydrogen bond. That's right here. And there are no coefficients here, so I don't have to worry about multiplying it. That's my total for my reactants. For my products, this is a triple bond here, and there are 3 of them. So I take my 1 triple bond and I multiply it by 3 because of that coefficient. And then I have 2 single bonds between oxygen and hydrogen. So the oxygen-hydrogen bond times 2, and I get a reactant total of that. Then I just subtract them, and now I'm getting a negative number, which tells me that energy is released and it's an exothermic reaction. So you have to know that, and you're going to have to label it. Okay, if you have any questions, all of this corresponds to the 7.16 classwork. The answers should be posted. If not, let me know. I'll see if I have it. If you have further questions on this, let me know. Send me an email. We can set up a chat, and take care, guys.